Selamat datang di Fakultas Teknik Universitas Mulawarman. Selamat datang di Center of Excellence for Tropical Studies. Pengembangan pendidikan keteknikan sudah dimulai sejak berdirinya Universitas Mulawarman tahun 1962, ditandai dengan adanya Fakultas Pertambangan yang berkedudukan di Balikpapan. Namun kemudian fakultas ini ditutup karena kesulitan koordinasi dan penyediaan sumber daya. Tahun 1999 dibuka lagi program studi D3 Teknik Pertambangan di bawah unit pelaksana program studi diploma. Tahun 2003 pembukaan program studi S1 Teknik Pertambangan, Teknik Sipil dan Teknik Industri yang diikuti pembentukan unit pelaksana Fakultas Teknik. Tahun 2004 program studi D3 Teknik Pertambangan digabungkan ke UP Fakultas Teknik, dan tahun yang sama juga dibuka program studi S1 Teknik Lingkungan. UP Fakultas Teknik didefinitifkan menjadi Fakultas Teknik pada 27 September 2007 yang merupakan hari kelahiran Fakultas Teknik. Tahun 2010 program studi S1 Teknik Kimia mulai dibuka. Tahun 2014 Mendikbud RI memberikan mandat dan izin 6 program studi yang menjadi jalan dibukanya program studi S1 Teknik Geologi dan S1 Teknik Elektro. Tahun 2019, Universitas Mulawarman adalah salah satu dari 43 perguruan tinggi yang diberikan mandat dan izin program studi program profesi insinyur. Penyelenggaraan PSPPI melalui Fakultas Teknik telah menerima mahasiswa dan meluluskan insinyur-insinyur yang profesional di bidangnya. Tahun 2020, 2 program studi dari FKTI digabungkan ke Fakultas Teknik, sehingga jumlah program studi yang dikelola Fakultas Teknik adalah 10 program studi S1, 2 program studi D3, dan program profesi insinyur. Fakultas Teknik adalah fakultas ke-9 dari 13 fakultas di Universitas Mulawarman yang terletak di kampus Gunung Keluas, Samarinda. Dengan jumlah mahasiswa mencapai 3.500 mahasiswa, dalam kurun waktu 2 dasawarsa, Fakultas Teknik telah menjelma menjadi salah satu fakultas besar di Universitas Mulawarman. Visi Fakultas Teknik menjadi institusi pendidikan tinggi bidang ilmu teknik berstandar internasional yang mampu menggali dan mengembangkan potensi sumber daya alam khususnya hutan tropis lembap dan lingkungannya. Maka Fakultas Teknik bertekad untuk menjadi yang terdepan dalam mengembangkan tropical engineering. Upaya mewujudkan visi Fakultas Teknik untuk menjadi yang terdepan dalam mengembangkan tropical engineering pada 2030, maka FT Unmul telah menyusun dan menetapkan 6 strategi utama. Strategi yang pertama adalah menetapkan pohon penelitian rekayasa tropis pada semua bidang keteknikan di Fakultas Teknik. Strategi yang kedua adalah menetapkan roadmap publikasi bereputasi nasional dan internasional hingga 2030. Strategi yang ketiga adalah menetapkan roadmap akreditasi nasional dan internasional hingga 2030. Strategi yang keempat adalah terus mengembangkan kualitas sumber daya manusia, khususnya dosen. Strategi yang kelima adalah terus mengupayakan terwujudnya rasio dosen dan mahasiswa yang ideal. Strategi yang keenam adalah mewujudkan tata kelola yang baik, akomodatif, adaptif, dan transparan. Fakultas Teknik pasti bisa.
kepada Tuhan yang Maha Esa, berwawasan lingkungan, berasas Pancasila, berbineka tunggal ika. Fakultas Teknik selalu berinovasi, mengembangkan potensi lokal, bermutu dan relevan, berilmu keteknikan, berkembang dan terdepan. Universitas Mulawarman Jaya, Fakultas Teknik bangga memberikan prestasi yang gemilang bagi nusa dan bangsa, membentuk lulusan teknik yang ahli, mandiri dan terampil di bawah panji-panji Fakultas Teknik. Segenap jiwa membuktikan.
Bismillahirrahmanirrahim. I think with us is around about 100 participants in Zoom. Already, I think we can start this program while waiting for the latecomers. Alhamdulillah, all praise to Allah, by whose grace and blessing we are all gathered here today to confer and hopefully to plot a course for the future of sustainable well-being. Peace and blessing be upon the seal of the Prophet and Messenger, Muhammad SAW, his family and companions. The Honorable, the Dean of Faculty of Engineering, Mulawarman University, our special keynote speakers, colleagues and friends, our beloved students, ladies and gentlemen. Good afternoon, everyone. Assalamualaikum warahmatullahi wabarakatuh. Our special greeting for Professor Takenori Hino from Saga University, Japan. Konnichiwa, Sensei. Dr. Tri Harianto from Hasanuddin University. Selamat siang, Pak. Also, good morning to Dr. Silu Bhochhibhoya from University of Twente, the Netherlands. Thank you for all being here. First of all, I would like to welcome you to International Webinar of Engineering Month, Tropical Engineering for Sustainable Wellbeing Series 3. My name is Juli Nurdiana, and I am a lecturer at Environmental Engineering, and I will be serving as your moderator today. In this occasion, we shall have outstanding discussion from our keynote speakers, whom I believe shall leverage our knowledge and understanding on the strategies of city development in soft soil. Before we start, allow me to inform you the program for this afternoon. We will start our day with Indonesian National Anthem, followed by the hymn of Mulawarman University and Faculty of Engineering Mars. Right after, we will then proceed with the presentation from our keynotes and finalize with question and answer. Dear all respected participants, please give our respect for our Indonesian National Anthem. Would be Faculty of Engineering Mars. Let us get ready.
Bumi
The next would be faculty. Sorry. Sorry for these small issues. The next would be Faculty of Engineering Mars. Let us get ready.
Fakultas Teknik beriman dan bertakwa pada Tuhan yang Maha Esa, berwawasan lingkungan, berasas Pancasila, berbineka tunggal ika. Fakultas Teknik selalu berinovasi, mengembangkan potensi lokal, bermutu dan relevan, berilmu keteknikan, berkembang dan terdepan. Universitas Mulawarman Jaya, Fakultas Teknik bangga, memberikan prestasi yang gemilang bagi nusa dan bangsa, membentuk lulusan teknik yang ahli, mandiri dan terampil di bawah panji-panji Fakultas Teknik. Segenap jiwa dan baktikan.
Shortly, you will be hearing presentation from our special keynote speakers. But before we get started, I want to take a few minutes of your time. With us right now, we have about 200 participants already attending in YouTube and Zoom. The organizer will provide the link for registration in the middle of the program, so you can fill it. So please kindly stay with us till the end of this program. The presentation of the keynotes will be available on Fakultas Teknik website after the program ends. You can claim for a certificate of participation after completing and submission the evaluation form. Now, moving along to our session, the very first presentation for today. We are pleased to welcome out first special keynote from Saga University, Japan, from Professor Takenori Hino. Konnichiwa, Prof. Professor Takenori Hino. I'm sorry.
Hello, konnichiwa.
Arigato. May I give you a brief introduction of Professor Takenori Hino? He is a professor at the Department of Civil Engineer and Architecture, Saga University, and adjunct professor from Department of Civil Engineering, School of Naval Architect, Ocean and Civil Engineering, Shanghai Jiangtou University, China. He heavily involves research and on geotechnical engineering and environmental geotechnique in soft ground. And today, he will be speaking to us on realize of softness of Areque clay in Saga lowland. Please welcome Professor Takenori Hino. Sensei, the floor is yours.
Thank you, Chairman. Can you hear me?
Yes.
Thank you very much.
Perfect.
Thank you very much introducing me, and also thank you very much inviting me today. The very good opportunity of this international conference or international lecture. Greetings from Saga Lowland, from Saga University. My name is Hino. I'm pleased to meet you today. And also, I'd like to try to speak Indonesian, Just a moment. I'm depending on my Google translation. Uh, Salam dari dataran tenda saga. Okay.
Yes, perfect.
Nama saya Hino. Okay.
Excellent.
Saya senang bertemu dengan Anda hari ini.
Super.
Okay. Yes, thank you very much. Once again, greeting from Saga Roland. I am Hino. I am pleased to meet you today. Uh, Today's my lecture topic. As Chairman already introduced about my topic. Today's I'm preparing the topic realize the softness of Ariake clay in Saga Roland. By the way, so my background photo. This is Saga Roland. Can you see everybody?
Yes.
Okay, thank you. Then so okay, so let's start my lecture. As chairman, I have only 30 minutes, right?
Yes.
30. Okay. So so may I start my lecture?
Yes, please.
Okay. Okay. So now I'm showing the PowerPoint slides. Everybody can see this, right? No problem.
Yes.
Okay.
Yes.
Okay. So I'll start. Thank you. Today's my lecture topic is realize the softness of architecture in Saga Roland. Uh, So firstly, so I'd like to introduce by myself, who is Hino. So in the left side of the figure is my research achievement using Japanese government database called Research Map. So if you are interested in me, then so please visit the research map in Japan. Then so please search please put my name Hino. Then after that you can see my research achievement. On the other hand, the right side of figure is my Facebook account. So in my Facebook account, I always show my handsome photo. So before I start my lecture, I always ask participants that am I handsome or not? What do you think about? So if you are also interested me in Facebook, so later on, so please become friend each other. So, if you are interested in my detailed information, please refer to this information, research map and Facebook. Okay, I move to the next. Today's my lecture outline. I'm preparing the four topics. So number one, parameters related to soil condition. The second is sensitivity of soil. The third is landslide disasters associated with recent earthquake. Then finally, so I want to make some of the concluding remarks. So firstly, the parameters related to soil condition. Number one, the representation of soil condition. So in this slide, what I want to say, everybody, that the sticky soil is juicy, the dry soil has few water, hard soil is well compacted, soil with high compressibility have large void. There is hardly any board in hard soil like stone. Even if we explain by the words, how to understand the degree of the state depend on each person. So it is necessary to quantity the state of soil and express. So next slide, I think most participants already understand this content, but I want to talk about this content. Element representation of soil condition. So firstly, the element representation of soil condition, water inclusion. So this one we can define as a relationship of mass. Then, so this is called water content. Then next is the closing condition. The this one defined by the mass divided by volume. So this parameter we usually use as wet density rho t or gamma t. On the other hand, dry density rho d or gamma d. Then the third one is the amount of boil. So this one defined as the relationship of volume. So this is called boil ratio E. Then final one is the percentage of water in boil. So this one also defined as relationship of volume. So this is called the degree of saturation SR. So when everybody start to study about soil mechanics, so this parameter firstly everybody study. So firstly, I'd like to try to explain about the parameter SR, degree of saturation. So when we talk about the element of representation of soil condition, why we check the degree of saturation SR? Everybody understand?
Yes, I believe.
Chairman, why we check the degree of saturation of soil? What what do you think?
Um,
Why we check the SR, degree of saturation? So I'm showing the reason in the bottom of this slide. So if we check the degree of saturation of soil, so if the value is 100%, that case the Pascal's law is established in the mechanical behavior of the soil. Therefore, we can simplify the mechanical behavior of the soil and sink. So on the other hand, so if the degree of saturation value is less than 100%, so in this case, the capillary action occurs in the soil, and the mechanical behavior becomes complicated. So actually, I'm a geotechnical engineering professor in Saga University. But if somebody asks me the behavior of unsaturated soil, it means from the viewpoint of degree of saturation, the value is less than 100%. So if somebody asks me the behavior of that kind of soil, unsaturated soil, I'm sorry, but I cannot solve the problem. So why, in the case of unsaturated soil, the behavior becomes very complicated so because of capillary action. So by the way, what is the Pascal's law? So what is a capillary action? So I just pick the information from Wikipedia. I think after that, if the participant interested in the mechanism, Pascal's law and capillary action, please check the more detailed information using any internet or Wikipedia. In the case of my information, so what is Pascal's law? Oh, this Pascal's law, also Pascal's principle or the principle of transmission of fluid pressure, is a principle in mechanics that states that pressure change occurring anywhere in a confined incompressible fluid is transmitted throughout the fluid such that same change occurs everywhere. On the other hand, so what is a capillary action? So sometimes so this capillary action called capillarity, capillary motion, or wicking is the ability of liquid to flow in narrow spaces without the assistance of or even in opposition to external forces like gravity. So when we check the degree of saturation, so if the value is less than 100, so because of the effect of capillary action, therefore the behavior of the soil become very complicated. So that's why, so when we talk about the element representation of soil condition, why we take the degree of saturation SR, it is the reason. So by the way, the next viewpoint also really basic in soil mechanics or geotechnical engineering, the modeling of soil. Even soil. with complicated structure can be modeled based on three principles of soil particles, water, and air. So right side of photo is observation result of Ariake clay in Saga lowland. Saga lowland. So when we excavate from the surface in this lowland, so soon we can find a very, very soft clay. It is called Ariake clay. So after we use the scanning electron microscope, then so expand the state. Then after that, we can observe as right side of the photo. So when we check this photo, so we can see a lot of white part. So here, this part is soil. On the other hand, so in the photo, so we can also like a black area. So black area is the void. Then finally, we can make simple of this soil structure to the right side as solid water and air. Then after we define the soil model like this, then at the right side of this figure, we give the some parameter as mass, m. So total mass is m. Mass of air is ma. This is equal to 0. And the mass of water is we define as parameter the parameter as mw. In the solid part is ms. On the other hand, so if we see the right side of this figure, right side of this figure from the viewpoint of volume, the total volume is B. The in the solid part BS. The void part is BB. The water part VW. Then the air part is VA. So after we define these parameter from the viewpoint of mass and from the viewpoint of volume, so after that, so we can calculate these parameter: water content, wet density, dry density, void ratio, and degree of saturation. So this is one of the example. Above is Ariake gray. Then the left side of the figure is undisturbed one. Then right side figure is disturbed. And when we conduct the soil testing using this Ariake gray, we can get the parameter of solid particle solid particle density low S as 2.65 gram per cubic centimeter. Water content is 150%. Then with density, low T, this unit is gram per cubic centimeter as 1.3 gram per cubic centimeter. So after we obtain this low S, W, and low T, then we can continue to obtain the next parameter, dry density, loading, void ratio, E, and degree of saturation, SR. I'm sorry, but I forget to calculate the value of rho d, E, and SR. So that's why I want to ask all the participants. So please try to calculate the rho d, E, and SR using the parameter from the soil testing, rho S, W, and rho T. So I want to make 3 minutes here. So please try to calculate it now. Please. Then please give me answer. I think today's this lecture, I'm inviting my two of my international students here. Hello, Jose and Suryadana. Ma-
Hello, Sensei.
Hello, so can you hear me?
Yes, Sensei, we can hear you, Sensei.
So now I'm asking all the participants to calculate the parameter of rho D, E, and SR. Please also try to calculate it within 3 minutes.
Okay, Sensei.
Then please give me answer later.
Okay, Sensei.
Okay?
Yes, Sensei.
Just a moment, please. 3 minutes. So if you can calculate the parameter of area grade, so please also try to calculate it in the case of decomposed granite soil, the below one.
Okay, Sensei.
Okay. Oh. By the way, the bottom side of this slide, I'm showing the playground in the spot in Saga. We can see the three children in this photo. The center is the Dr. Tori Harianto from Hasanuddin University's son.
Oh,
Thank you very much, Sensei, to
Thank
show
you.
my son's picture. Thank you
Yeah,
very much.
yeah. So I want to say gambatte, right?
Make it Hari Jose.
okay, Sensei. Okay, Sensei.
Yeah. So time is already 15 minutes. Okay, so I will continue. So Jose, later on, please check my answer. Eh?
Okay,
So
Sensei.
in the case of Ariake Clay, so if I calculated the value of rho d, maybe rho d value is equal to 0.52.
Yes, Sensei. Exactly.
Luckily, okay? Then
Yes.
the boild ratio E of Ariake Clay is 4.1.
Yes, Sensei.
So the degree of saturation should be 97%. My answer
Ye-
is correct.
Yes, Sensei. Exactly. I just finished
Oh, okay.
calculating.
Then I can continue as I am professor. So on the other hand, how about the case of decomposed granite soil below one? The
okay.
load should be 1.8, right?
Yes, I'm trying to calculate the.
You really?
Yes.
Then the boild ratio should be 0.46, okay?
Yes, Sensei.
Honto? Then the degree of saturation is 57.6.
Uh, I found 58%.
How many, sorry?
58. Almost the same thing.
Oh, okay. So the value also okay. So I believe every participant, if somebody asks you to calculate these parameter, so I wish everybody can soon resolve this parameter, right? So because this is really basic of soil mechanics. Okay. No, one day when I visit one country's one university, then I gave the lecture that time. That time a lot of very excellent student was there. Then everybody told me that teacher, professor, I we are really good at mathematics. Oh, then so said everybody, oh congratulations. So by the way, the what is water content? Nobody answer me. What happened? So therefore, so that's why actually my topic is a really basic one. But when you are truly geotechnical engineer or geotechnical engineering researcher, so this kind of state parameters please uh, become soon resolved. Okay. Actually, I don't know now what kind of textbook all the participant is learning, but this is also one of the way to solve this kind of problem. For example, in the case of algebraic ray, so please memorize the value of lowest is 2.65 gram per cubic centimeter in your notebook. Also, the water content W is 150%. Then the wet density load is 1.3 gram per cubic centimeter. So please memorize your notebook. Then after that, so using this map, so firstly, please put B as 1. Then after that, so next step, second step is we can soonly solve M. What is the value of M? Then third one, so please also solve the MS. Then so if you can get the value of MS of right side of this figure, so because we already know the M, so total mass M minus MS is equal to MW. Then we can give the number like that. Then so next, so please go to the volume. So please go also try to solve the BS. Then so next obtain BW. Then the total B as primary I set the value of B as 1. So 1 minus VS minus VW. Then we can also solve the VA. Then after that, the VB is equal to VB VW plus VA. Then like after that, so we can give the all the number for all the parameter. Then actually, when you get this kind of problem, actually your textbook try to teach you a really complicated equation. But so, for example, in the case of water content, so what is the basic definition? In the case of water content, is equal to MW divided by MS times 100 then percent. So if at least you remember the primary definition of each soil parameter, and after that, if you can give the all the value using so this low s, w, and low t number, then after that, remain parameter low d, e, and sr, you can soonly calculate it as simple. So I'm sorry, but if I use time or only this viewpoint, maybe I cannot finish my lecture. Then finally, what is very important for all the geotechnical engineer or geotechnical engineering researcher, after we obtain the soil parameter, so most important thing that can you imagine that this state in the case of allylitic clay, right? So mostly in the volume, water occupy. That's why very soft. Or the solid part is very few in allylitic clay. That's why allylitic clay is very soft. On the other hand, the decomposed granite soil, like a playground, so please also imagine the state of soil, water, and air. Why we go to, well, we visit the playground, we feel very hard soil because the very few water or very much solid. So that's why we feel that we feel the soil is hard. So after you calculated this parameter, so please also reach to this imagine. So in the one volume, so how many or how much solid occupy, or how many or how much water occupy. Then after that, please consider that, okay, after we obtained this kind of parameter, the soil is soft or the soil is hard. So it is really the viewpoint of the start of soil mechanics. So if you agree my opinion, so please try to imagine so this state in the future. Then second is the sensitivity of soil. The quick clay landslide at Lisa, Norway in 1978. The quick clay developed by in Norway. Then I think it's almost 6 years ago. The one famous professor whose name is Bieran in 1954, he showed that this data. So this is a soil profile of one Norwegian clay. So please check the value of water content and the consistency limit, and then the shear length. The most important thing that please also notice the right side of this figure. We can see that the parameter of ST. So in the case of Norwegian clay, if we check the sensitivity, the upper part of this foundation, the sensitivity value we can see that's as 75. But if we visit the below, the value is 500. What meaning of sensitivity? The sensitivity equations, I think you can check in the textbook. The equation is like this. ST is equal to QU divided by QUR. Where is QU is the unconfined compression strength of undisturbed soil. On the other hand, QUR is the remodeled strength of disturbed soil in unconfined compression test. So after we obtain these QU and QURs, we can calculate it as ST. So this is a equation meaning of sensitivity. But on the other hand, so like Ariatic ray, so you can see in this figure, so if undisturbed state, Ariatic ray can stand up by itself. But after that, we remolded the Ariatic ray. The Ariatic ray so become really like liquid. So I'm preparing tea here. So really, and after the disturbance, the Ariatic ray so become liquid. So in that case, we cannot apply this equation. So therefore, especially, so if we want to measure the remote strength of disturbed soil, but we cannot apply the unconfined compression test to the reticulate scale. So in the that's why when we measure the remote strength of remote strength of a reticulate, we always use this bench shear testing equipment. So, but please notice that so if you use a laboratory bench shear test to check the remote strength, so in that case, please also extend the equation of sensitivity from first one to second one, like this. Because actually, the basic equation of the sensitivity from the viewpoint of mole circle, so we compare the value as it depends on the x-axis. But if we use the laboratory bench shear test to check the remote strength, so in that case, so we must depend on the y-axis viewpoint. So in this case, so sensitivity equation also change from the original one to like this. So then after we check the sensitivity, so this graph is one example of a related play. So actually, left side of this figure is the information from the quaternary. Then right side is ordinary soil testing result. So according to this result, the right side of this graph, we can see the ST, the sensitivity ratio of acidic grade is averagely 50. But so in the case of this data, so that at 10-meter depth, please check the value. The sensitivity ratio is about 300. This means, so what the meaning of this sensitivity? In undisturbed state is stand up by itself. But after remolding, so drastically change from the solid state to liquid state. So this is typical characteristics of Ariake clay. So the origin of the viewpoint of sensitivity is from Norway by Beram. Then after that, our research group in Saga Lowland area, we also continue to check the sensitivity ratio of the soil. Then sometimes we get this kind of result. Thereafter that, so we continue to consider to design the embankment or countermeasure for soft ground, something. So that one, Saga University Group always consider the design and construction method using this sensitivity. By the way, the why the soil sensitivity become high? Actually, the mechanism. If I talk about everyone, I need more than 1 hour. So one of that's why I try to explain as simple. Maybe if you find so very high sensitivity clay, maybe the structure is right side of this figure. So this is a osteoporosis illness, the bone structure. So right side of this figure is okay, good, good health. But left side is good health. But the right side case, the bone become very weak. Why? Because the density become very low. I think so. If you find a very high sensitivity clay, maybe the imaging of the soil structure is really like the right side of this figure. So finally, then when we take this kind of parameter, so what we can continuously consider the mechanism of the soil behavior. For example, this is landslide disasters associated with recent earthquake. So this one, the 2018 Hokkaido Eastern Erie earthquake. So just 2 years ago, so Japan hit a very serious earthquake. Then a lot of landslide disaster occur in this year. On the other hand, at the same time, so for Indonesian people also had serious damage. 2018 Indonesia Sulawesi earthquake. So that time, so especially Petobo, Palu, Indonesia, the damage is really serious. Especially the very, very big landslide disaster occurred at that time. So now many researchers try to solve the mechanism of this big landslide disaster. Why today I'm preparing my sensitivity ratios viewpoint. So in the future, so when you consider the mechanism of landslide disaster, please also worry about the soil structure. If the soil structure, especially the sensitivity ratio is really high, then after that, if the earthquake hits there, so after that, maybe the very big landslide disaster occur. So it is one of the possibility mechanism. So up to this time, when we consider the mechanism of landslide, nobody talk about the soil structure sensitivity. So in the future, I strongly believe that to check the sensitivity ratio, even the state parameter of the soil more seriously, I think we can obtain the more detailed mechanism or information about landslide disaster. So that is my lecture's opinion. Finally, I will make concluding remarks like this. Among the various soil data introduced in previous soil mechanics, it is thought that there are many opinions that are being guided without well understanding of the sedimentary environment. Reconstructing the initial depositional environment for comparison with the current geoenvironment, clarifying the mechanism of processes that cause such difference, and clarifying the effect of such mechanisms on the current environment are the unique approach adopted in the Saga lowland area. Such an approach had been possible for the area because the area is blessed to have related its original plain landscape since it was formed. We hope that data are collected based on a similar approach of this study nationally and internationally. And we hope to have opportunity to discuss this as the same base of research. That's all today's my lecture. Thank you very much for your listening.
Yes. Setsume arigato gozaimasu. I hope I spell it right. Thank you, Sensei, for interesting talk. So we will shift to the next, our second special keynote, Dr. Tri Harianto. But before that, I would like to remind all the participants first that the link for the question you can already fill in. You can find in Zoom and also the YouTube. And also, we will provide the link for attendance in the middle of the program. So please kindly stay with us till the end of the program. Also, with that link, you can claim for a certificate of participation after you submitting the evaluation form. Right now, we have around um, Sensei would be pleased to answer them. Let's allow me to introduce our second special keynote, Dr. Tri Harianto. Assalamualaikum, Pak Tri.
Waalaikumsalam warahmatullahi wabarakatuh.
Ya. Siang, Pak. Let's allow me to introduce you a brief.
Siang. Konnichiwa.
Dr. Tri is Doctor of Engineering, Faculty of Graduate School of Science and Engineering from Saga University, Japan. He holds a Master of Engineering from Faculty of Civil Engineering and Planning, 10 November Institute of Technology, Surabaya, alma mater saya tuh Pak Tri. And also hold Bachelor of Engineering with honors from Faculty of Engineering, University of Hasanuddin, Makassar. To Pak Tri, the floor is yours.
Okay, thank you very much, moderator. So may I share my screen?
Yes, please.
So can you see my screen now?
Yes.
Okay.
Yeah.
Okay, it's fine.
Okay. Yeah. Cool. Perfect.
Cool. Okay. Yeah. Good afternoon, everybody. So, Assalamualaikum, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today, I would like to give a lecture about the soil reinforcement. So I will talk about the state of the art of the soft soil reinforcement in Indonesian practice. So previously, Professor Hino already gave a lecture about the soft soil basic knowledge or basic concept of soft soil. So I will not go to that part because already lecturing by Professor Hino. So now I will talk about the application of the reinforcement of soft soils. Okay, so I am from Civil Engineering Department, Hasanuddin University, and then according to the moderator, you already hear my CV. So let's start the lecture now. So before I start my lecture, I would like to introduce the outline of this presentation. So first, I would like to talk about the general understanding of the soft soil, not in detail because Professor Hino already mentioned in the detail in the previous lecture. So I just want to talk about the more general behavior of the soft soils. And the second one, I will talk about the origin of soft soil. And then last part, I will talk about the case histories. So I choose two cases that actually these cases is PhD dissertation of our PhD students. So one case in the Kalimantan and in the Kalimantan Timur or East Kalimantan, and one case is in the Makassar city. So to the general understanding of the soft soil. So soft soil becomes soft when interact with water. As Professor Hino mentioned before, if you put water in the soil behavior changes. So clay shell and expansive soil upon wetting, that is the behavior. If you have a clay shell and expansive soil, and then you give them water, or water infiltrate to the soil, so the soil become soft. And another example is if you have an uncompacted field, softened due to the water infiltration. So when you didn't do the proper compaction to your soil layer, and then there is a crack in the soil, the water, if for example, in the rain, water can infiltrate to the uncompacted field. And then soil originated from volcanic aces. So one example of the subsoil is if the soil originated from volcanic aces. So about the volcanic aces, when I was doing my PhD, my topic about the volcanic soil. So this is the main samples of my research topics in the when I was doing my PhD in Saga University, Japan. So again, subsoil typically characterized by, so this is the characteristic of subsoil. First is subsoil usually have a low shear strength. And then secondly, subsoil also highly compressible. And then has a low permeability. So can you see the figure in the below of this slide? This is one example of the damaging or catastrophe medium in the subsoil. So you can see the high-rise building is going down, and then in the road we can see the landslide occur in the road, like in this slide. So after that, let's talk about the origin of the subsoil. So in this slide, you can see this is the Indonesia island. So we have a big five big island. So the green color is indicated the subsoil. So and then the green color with the dashed line is indicated the pit soil. So generally, subsoil in Indonesia is considered is a quaternary sediment, consists of alluvial deposits and organic or pit soil. So especially in Kalimantan, especially in the central of Kalimantan, we found so many pit soil. And also in East Kalimantan, I think in the Kutai Kertanegara district, I think, I will introduce it later. We have also pit soil. Pit soil is a problematic soil. So we need a lot of budget to overcome the problem arise from pit soil. And then soft soil or soft ground usually found in the coastal plains and cover large area. As you can see in the figure, you can see that most of the soft soil is in the shoreline. For example, in the Sumatra Island, you can see the soft soil located in the eastern part of Sumatra. And also you can see in the Kalimantan Island, so the soft soil located is in the southern part of Kalimantan and also in Papua. And in Java, you can find in the northern part in the island of Java. So this is the distribution of soft soil in Indonesia. So we can see, if we talk about the East Kalimantan province, so we found so many soft soil, especially in Samarinda. This is the Kalimantan East Kalimantan province, and then we found that in this green area is a soft soil, but in the middle, in the center of East Kalimantan, we can find the like a pit soil deposit. It's very huge area, pit soil. So this is also problematic. And then I heard that the new capital city of Indonesia will be around here. So that is a big task for us to overcome this kind of problem. So if I enlarge this map, we can find the Samarinda. I think you are all in the Samarinda. So in the estuary, you can see the green color. So all the estuary is covered by green color. It means it's a soft clay. So this is create some problem in your in the Samarinda city also. Some part in the Penajam Pasar Utara and then Balikpapan, some part. But most of the soft soil near in Samarinda, because Samarinda is located near the estuary. So this alluvial sediment deposit in the estuary. So this is the problem we face in the city of Samarinda. So as I mentioned before, construction on soft soil has a risk damages or failures. I can already show you in the previous lecture, previous slide. And then most of failure are contributed by lack of knowledge on soft soil. Why I want to mention about lack of knowledge, as previously Professor Hino mentioned about the behavior of soft soil. So in general understanding, the consultant or construction officer usually don't have a very good in knowledge about the soft soil. They just build everything based on the experience of something. So therefore, so I really enjoy Professor Hino's lecture because he teach us about the behavior or knowledge of soft soils. So I hope after you took this lecture, you have at least you have a knowledge about the soft soil, because your city, Samarinda, have a problem of the soft soil. Okay. So as I mentioned before also that I will talk about two cases about how to overcome the problem of soft soil. So at the first, I will talk about the topics about the field investigation of the performance of soft soil reinforcement with inclined pile. So this paper I already published in some conference in Australia a couple of years ago, 2016. So in this conference, I talk about the using timber pile. I think you are all familiar with the timber pile, and then as a reinforcement equipment. So yeah, this is a soft soil distribution in Indonesia. I already mentioned before. So the field test location located in this is Kalimantan province. So this is related to your area. So before I start continue about the how we overcome the problem, so I want to introduce that this is the problem of soft soil. You can see the car. So the car is totally going down, downward from the top of the road. Actually, this is the top of the road, and then you can see the car is already down. You cannot see the car if you are not go in near by the car. So this is the problem in the soft soil. You can see in the left, this left upper side. This is my picture. I just want to prove that I have been to this kind of problem. So only like a selfie moment. Okay, so quite bit selfie in here. So and then another thing we can find that this is the problem of the soft soil in the road, and then we can see the road like this. This is the real happen in Indonesia, in Kalimantan also. This picture I took in Papua, in Merauke. So almost similar situation. You can see the long queue of car. This is due to this kind of problem in the right side of problem, because the car cannot pass together, just one by one. So we are in the big queue at the time. So this is the problem we face in the road construction. So let's go to the solution. So first of all, I would like to introduce you what kind of material we use in this study. So in Kalimantan, we know we have so many timber called galam. Yeah, so galam timber. So we can easily find in Kalimantan. So what is the advantages of this timber is easy planted and rapid growth. So yeah, we use this material as a material of reinforcement. One of the reason is because we usually think about the environmentally friendly material. So we cannot use concrete pile because we use cement, and then we cannot use any non-friendly material. So why we choose timber? Because it's environmental friendly material. So this slide, I want to introduce the reinforcement arrangement. So inclined pile, we put in the one group. So each one group of pile consists of 3 piles. So one is vertical and 2 is inclined, like this. So the pile is local timber. We call it galam here. I think you already have know the galam. So in this study, we have a 3 kind of pattern of study. First pattern, we call it type 1, only geotextile without any pile. And then the second pattern, second type, we put conventional pile. Conventional pile means it's driven vertically without any inclination of pile. And the last type, we call it inclined pile. We combine between vertical and inclined pile and then put it together as a group. So this is the detailed arrangement of each type. So all the embankment reinforced by geotextile, 3 layers of geotextiles, and then we put the instruments inclinometer to measure the inclination of the soil after subjected the load, and then we have a settlement plate here. Settlement plate is for measuring the settlement of the embankment, and then piezometer. Piezometer we use to measure the pore water pressure of the soil during the construction or during the preloading. This is the type number 1. This is the type number 2. We only the same arrangement in the embankment, and then before we put the embankment, we insert the vertical pile here. So insert the vertical pile from galam, galam, and then the same equipment, monitor equipment, we put settlement plate, piezometer, and then inclinometer. We put in the same location with the type number 1. Type number 3, inclined pile, also same. And then only the difference between the 2 types, we only put the inclined pile in the structure. So these 3 kind of structure we study about the behavior for the after subjected the load. This is the arrangement of the pile. So each pile group consists of 3 piles like this. You can see the arrangement like this, and then we connected each other with the wire like this. The function of this wire to make it stiff, not to move during the loading. And this is the inclined pile arrangement. And then this is the picture while we install while the pile installation. Okay, so you can see. So one is the benefit of this techniques or this method, that we don't need any special equipment to install this pile. We only use the simple light excavator and then push the pile downward. Why we don't need use the special equipment? Because it says soft soil. Soft soil, we can easily insert the pile to the ground. So why this is the one benefit of this method. After completed install the pile, so this is the arrangement. You can see here. This is the yellow bars here. The yellow bars here is the settlement plate. You can see many yellow bars here. This is the settlement plate monitor. Okay, this is the stratigraphy of the soil in the location and in the field location. So this is the red color here, indicated the location of our study. So you can see here the soil is like this one is a very soft soil, and then you can see layer up to soft clay. can see the depth up to 25 meters. We can find the soil is very soft. Here the characteristic soft clay we can find here in the purple color. Yeah, so very thick soft soil deposit here. So this is the result from CPT and deep bore. So we can find that the very soft clay from surface to up to 4 meters, and then from 4 meters to 12 meters is a soft clay, and then 12 to 25 a medium clay, and then below that medium clay we found the sand. So this is the value of SPT. SPT is standard penetration test. This is this data we collected from field investigation. So people maybe wonder what is the inclination of the pile. So we choose the inclination of pile is 15 degrees. Why? This is the reason. This is the reason why we choose the inclination of the pile 15, because we already do it in the numerical analysis, and we found that the smallest settlement we found in the 15 degree of pile inclination. So in the study, we chose the inclination of pile 15 degree according to this numerical study. So this is the result during the loading. So this is the geotextile, the pore water pressure profile. This is the geotextile, conventional pile, and inclined pile. So we have 3 data for each measurement equipment. So in this figure, we can find that the inclined pile has a very small lateral movement like this. So between the geotextile and then the inclined pile, there is a 75% reduction of lateral movement. So it's indicated that this inclined pile is quite good in overcome the problem of lateral movement. So according compare with the geotextile itself without any reinforcement like a pile. So this is one finding from this study. And then another thing, the total settlement, if we compare of the three types of pile, so geotextile here, and then in conventional pile here, and then the lower one is the inclined pile. So you can see that reduction of the settlement by using the inclined pile is 60% compared to the geotextile. So it's a huge reduction of settlements. That's indicated that our inclined pile is working very well in soft soil. So the conclusion of the part number 1. So the bearing capacity of reinforced soil, conventional and inclined, sufficient to support the trial embankment. The total settlement reduction, both the incline and compared, is 52 and 65, but 65 is with inclined pile. So inclined pile is more superior than vertical pile. So therefore, the inclined pile reinforcement has a potential application for road construction as an alternative in construction method. This is the conclusion for the part number 1, and then let's go to the part number 2. I hope I still have time. Okay. So the second one, this is also our study. This is my master students. Yeah, we published this paper in the SAM conference in France, 2017. So the title is a full-scale test of causeway embankment supported by rough aggregate column foundation or soft clay deposit. So this research project is conducted in the construction of a new port in Makassar city. So this is location. So recently in South Sulawesi or in Makassar city, we constructed a new port in this area. So we conducted a study about the soil reinforcement in the marine soil in this area, in this project. So yeah, this is some figure of the situation, soil condition in the shore area or in the marine clay. We can see the black color in the upper left picture. We can see the black color of soil. That is a marine soil. It's very soft, like Ariake. So Ariake is very unique soil because only we can find in the Kyushu Island in Japan. So here also this is marine soil, but we don't have any name yet for this soil. But very soft, looks like Ariake clay that a person Hino mentioned before. So this is the method how they dredge the sediment from the bottom of the sea, and also like this. So they will excavate the sediment and then put the reclamation on the top of this area. So this is the Newport project. Same with the previous study. This is the boring log result from research area. So we can see here the soft clay from the surface up to 4 meters downward. We can find that clay with brown colors, it's clay with gray color. So very soft. According to the SPT value, the soil is very soft. Now, less than SPT failure number is less than 2. So it's very soft. This is the soil stratification. Again, we use environmental friendly material. So in the previous section, we use timber gallam, and then here in this project, we use bamboo. So we have 4 layers, 1, 2, 3, 4, 5 layers of bamboo, and then we put it as a raft because we are working in the water. So we need a kind of structure like a raft to make the structure is not floating down, not going down, it's just floating in the water. So I think the same reason why we use bamboo, because easy planted, rapid grow, and then we can easily find anywhere, especially in Makassar, we can easily find bamboo. Okay, the aggregate material. So we use a mixing between sand and the boulder, and then we put in the column like this, and then insert to the soil. So this is in the location, and this is the near the shoreline. And then this is how they install the pile. This is the arrangement of the soil reinforcement. So we only have an aggregate column, consists of boulder and the sand mixed together. So the thickness, the length of the column around 4 meters, and then 3 or 4 meters, and then diameter is 80 centimeters. So we have a four aggregate column in the study, and then we have a settlement plate to measure the settlement during the construction of loading. So we have a woven geotextile and then bamboo mattress, 2 layers here, below and the top. Okay, and then this we compare 2 types. The type number 1 without any column, and then type number 2 we have a column aggregate as a reinforcement. So this is the arrangement of the column, and then this is during the installation. So what we found here, so we still use a very common equipment or heavy equipment to install the pile. So we only use an excavator. No need. We don't need the special equipment to push the pile go down to the earth or go down to the ground, because the soil is very soft, so easy to push. And then during the installation, and it's almost finished the installation like this, so it's very easy. And then this in the left, we can find at the top left, we can find that this is all the already installed, all the column already installed in the study area. After that, we put the bamboo raft and the top of the column, and then cover it by geotextile. What is the purpose of this geotextile? To prevent the granular material not going to the water like this. This is the almost finished the loading. So this is the result. So the tile embankment observation with bamboo raft, only bamboo raft. So we found that the settlement, total settlement around 0.8 meters. And then when we combine with the column aggregate, we got the settlement 0.64 meters. Not so big difference, but this construction, this is the early stage, not finished. Still early stage of the construction, because the time limitation, we only measure about 120 days. So actually the consolidation happened maybe like a year or 2 years, but we only measure in the early stage. Why? Because it's time limitation of the study. Yeah, because we don't have any budget to continue for until the total consolidation finish. Okay, so and also in the study we can find that the correlation between embankment height and elapsed time. So for example, in the loading period, like loading time 30 days, so without without aggregate column, we can only put the head of embankment like less than 3.5. But if you use the rough aggregate column mixing like this, so in the 30 days, we can go to 3.6 meters. So it means by using aggregate column, we can shorten the period of we can shorten the period of time loading, and then we can increase the height of the loading, embankment height. Like so, the one of the benefit of this method of techniques. And also we can find that the predicted degree of consolidation of rough aggregate column. So they almost in the finish the consolidation. Yeah. So our student also make some calculation compare with the field investigation, and then using ASAOKA method, and then calculate it manually by 1.3 on 3D software. So they found that not so much different between field investigation and then calculate it, and also ASAOKA method. Okay, let's go to the conclusion. So the performance of the rough aggregate column compared to rough itself, so a reduction of settlement by about 25% in 120 days observation. So yeah, there's one benefit. And also the rate of settlement of rough aggregate column foundation is much higher than the rough foundation itself, due to the aggregate column behave as a vertical path to allow the excess pour water pressure dissipating. So this is the conclusion of our studies number 2. I think that's all. Thank you very much for your kind attention. I hope you are not sleepy. Yeah, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih Pak Tri. Thank you very much for the insightful talk. For your information, that we will combine all discussion session for all the 3 speakers after the third keynote presentations. Also, this webinar you can find live on YouTube, Instagram, and also Facebook of Fakultas Teknik Universitas Mulawarman. Right now, we have around 400 participants join us today. And also, this webinar, series 3, will run till the end of this month. So the whole month. You can find the information in the Facebook or in the website of Fakultas Teknik Universitas Mulawarman. Now, dear participants, let's shifting to our third keynote. Please welcome Dr. Silu Bhochhibhoya. Hi, Silu.
Hi.
Are you there?
Yes, I'm here.
How are you?
I'm good.
Hopefully it's
Thank
not
you.
gloomy there this morning.
It's a bit sunny this morning.
Wow, that's cool.
You can see the sun rays.
Okay, nice to have you here.
Thank you for
Allow
inviting
me to
me.
mention a brief about Dr. Silu. Silu is an assistant professor at the Department of Construction Management and Engineering, University of Twente. Her Ph.D. in Sustainability Assessment of Building System in Himalayan region. Her research area includes environmental sustainability, life cycle assessment, life cycle costing, carbon footprint of construction material, culture, indoor environment, bioinsulation, and alternative building material, as well as circular economy. So if the two previous speakers talking about the soil, right now we give you the information about upper, I don't know what to call it, but hopefully you know what I mean. Sorry for this. So Silu, the floor is yours.
Thank you very much, Juli, for inviting me for this lecture. My presentation is quite different than previous lectures, but maybe interesting for you. I'll be talking about the circular economy in Dutch housing sector. As Juli already introduced me, I'm Silu Bhochhibhoya, an assistant professor at Department of Construction Management and Engineering. And I do research and teach on how civil infrastructure like bridges and roads, buildings can be more circular and sustainable. Let me discuss the broad concept of circular economy first. When we see around us all the material or the goods like a laptop, phones, books, building that we have surrounded, what we are doing is like we take the materials from the natural resources and we make them, use them, and then ultimately we dispose them. So currently we are living in the linear economy, building economy, which we uses the raw material from the nature, we manufacture them, and we use for them for the certain period of time, and then we either dump into the landfill or incinerate. Can anyone tell like what are the disadvantages of having linear economy? You can write the answer in the chat box. I can't because I'm sharing the screen, so I can't see the chat box. If there are some answers, then Juli, can you check?
Sorry. Yes.
Yeah, I asked like, what are the disadvantages of living in the linear economy?
Oh, I see. Okay.
So if there are some answers in the chat box, then yeah, can you check for me?
Okay. Yep. I will. Okay. I think all of us willing to hear your explanation, Silu.
Okay, no problem.
Yeah.
Here. No problem. In the linear economy, we are consuming tremendous amount of natural resources, which are finite, and also producing high amount of waste production and also the CO2 emission. So this is the living mode that we are living in the linear economy is not the sustainable mode. So what we can do is like adopting the circular economy that radically reduces the use of natural resources and also reduces the production of the waste and CO2 emission. And the circular economy aims at closing the loops and also instead eliminate the waste by intervening in each of the life cycle stages of the product. So I can give you some examples. In different life cycle stages like production, distribution, and composition, we can apply different circular economy principles like reduce, rethink, redesign. And in distribution life cycle stages, we can adopt remanufacture, repair, reuse. And in the consumption, we can reduce, recycle, and recover the energy. So here are some examples of what I mentioned previous slide. So in the production, you can adopt the eco concept, like using a timber frame, or maybe using the bamboo for reinforcement for the settlement that the previous lecture mentioned about, and adopting the eco design of using the LED bulb instead of CFL, because it doesn't use mercury and also use significantly less energy compared to CFL. The product service system is kind of like bike sharing, and also selling the Kindle rather than books in Amazon. And extended warranty is increasing the durability of the product. And the industrial ecology is like substituting the cement by using a fly ash, which are the byproduct of the coal burning. And also use of biodiesel and biofuel for transporting that goods from the manufacturing company to the site, to the construction site. So in the distribution, one-to-one returns could be an example of the jeans company where they sell the jeans, and after using for some period of time, you can return that jeans and then get another one. And the deposit system, you can deposit the bottle and get refund. And hiring and leasing could be like leasing a bike or car. Or here in Netherlands, they can also lease the movable house or tiny house for a certain period of time. In the consumption reuse center, there is in Netherlands, we have also like Marktplaats or eBay, where you can sell the secondhand product, which can be reused again by another second user. And repair cafe, there are several repair cafe in Netherlands where the people meet together and repair the household electrical and mechanical devices such as computers, bicycle, etc. Recycling park, floating park in Rotterdam is one of the good example where they use the recycled plastics. And sharing economy could be like carpooling, B&B, etc. So, according to the Ellen MacArthur Foundation, the circular economy is an economic and industrial system that restorative and regenerative by design, which aim to keep the product and component and material at the highest utility and value at all the time in both technical and the biological cycle. Technical cycle are mainly those material which are finite, for example, steel, aluminum, etc. And the biological is more like food, clothes, which are biological, which can be decomposed. The Circular Economy Action Plan in Europe, or say in Netherlands, like the 80% of the environmental law in the Netherlands have been created by the EU, European Union, and has developed a circular economy action plan, which ensure that the circular economy concept will be at the core of future development in the region. So the summary of this principle of the action plan is the future is not in the low-cost production. The future is in the product that are used and reused time and time again. The government-wide program of circular economy is aimed at developing a circular economy in the Netherlands by 2050. So by 2050, Netherlands wants to be a carbon neutral and also be nearly 100% circular. So they have this very high aim targeted to be carbon neutral and circular by 2050. So, and also they are mediated milestone, like by 2020, it's like reducing 20% of CO2 emission, and by 2030 being energy neutral. Similarly, in the circular economy, by 2030, they want to operate the infrastructure procurement in the circular way. And by 2030, reducing the 50% of the raw material. That means reusing the raw material again and again. And by 2050 is zero waste. In Dutch government-wide program, they take in account 5 priority sectors. They are consumer goods, construction, plastics, biomass, food, and manufacturing. So construction, so my research is focused on the construction sector, and most of the construction now are adopting the circularity in their product as they have to meet circularity by 2050. So all the Dutch construction company are adopting circularity in their product. So I have here 2 case studies from my master's students. And the one is the transition of circular economy in the Dutch housing industry. So in this study, we have inventorized the sample group of 34 Dutch construction sector that we fit with 6 resolved business objectives that are regenerate, share, optimize, loop, virtualize, and exchange. The regenerative objective is used by 10 contractors that we have interviewed, and that mostly choose for more bio-based material, like building a house by timber. The business objective of sharing is used by only 6 companies that specialize in constructing the movable house. So the companies that can reuse the movable house by reselling them and moving them to another location. The 15 companies that opted for an optimized business objectives that all focused on making their housing concept modular and demountable. Sorry. And the business objective loop is used by 7 companies, mainly through the reuse of the materials. The virtualized business objective is used by 9 companies that we have interviewed, and that all make use of Madaster. In Madaster is a database that keep all the track of the information of each of the material that are used in the construction project, which can be used mainly in the demolition of the building. The 6th business objective is exchange, which is use the list of all the objective, namely three construction companies use them among our sample group. And the companies that are using exchange as an objective have developed a circular renovation and develop a new insulation material and that are composed out of typha glue, which is received out of the plant. So taking into account the Schumpeter's business cycle and looking at the characteristic of the building that we have sampled, we mostly resemble that the Dutch housing construction sector are still in the introduction phase. Because the market for circular economy is still relatively small compared to the traditional house. So this second case studies is about exploring the relationship between the level of circularity and the life cycle cost of one family house. In the last couple of years, many construction companies have shown the increased willingness to move toward the circular business because they have to be circular by 2050. So, however, many considered circular construction to be a more expensive option, right? Which makes actors reluctant to invest in circularity. So these studies are focused on relationship between life cycle cost and the circularity level of one family house. Yeah. So to this study, we adopted the Building Circularity Indicator by Fairbairn 2016 to measure the circularity within the construction industry. In that case, we first evaluate the material indicator, MCI material indicator building, and then we then analyze the product design and the systems and the lifespan of the building. So in each step, we calculate the building circularity indicator from the material till the whole building sector. So we form the scenarios in different building layers. So we take in account 3 building layers that are structure, skin, and space plan. The baseline, the concept circular house are prefabricated concrete without recyclable content, and the skin they use the brickwork, glass fiber insulation, and concrete roof tiles. For the space plan, they use gypsum block wall and anhydride finish floor and ceramic tile. And then in different scenarios, we change more bioproduct, more recyclable material in different building layers. So we found, we calculate the building circularity level in all these scenarios. The baseline is 0.20, whereas the final scenarios is 0.49. In scenarios 1 and 2, we use recyclable and bio-based component. In scenario 3 and 4, we use dry connections, and we change mostly the structure part in the scenario 5. And we can see the results of life cycle cost with the relationship with the circularity level. So here we take in account different life cycle stages: the product cost, the construction cost, operation cost, and the end of life cost. So in the product cost, with the increase of circularity level, there is also the increase in the product cost. Similarly, in the construction cost, the cost increases with the increase of the circularity level of the building. However, in the operation cost, it decreases with increase of of the circularity level. And in the end of life cost, it significantly decreased with the increase of circularity level. Here you can see the bar graph of different the life cycle cost of different scenarios. And what we found is that the scenario 4 has a good level of circularity level, and also in terms of cost, it is much lower compared to scenario 5 and final scenario. So we considered the scenario 4, because in scenario 4 we don't have to change drastically on the material and also in the design, whereas in scenario 5 and final scenario there is a tremendous like changes on the building, and compared to cost, it's very costly than scenario 4. So we prefer, so from this research we found that scenario 4, which has a higher circularity level and also less life cycle cost in terms and compared to other scenarios. So to conclude that the Dutch construction sector is still in the initial phase, but when we compare with other European countries, we are still the front runner. And when we compare with circularity and life cycle cost, even though it's costly compared to a traditional building, but in the long run, it's profitable. So I suggest you to adopt the circularity, even though in the investment cost is high, but in the long run it will decrease significantly. Thank you.
Thank you very much, Silu. It's very interesting examples from the Dutch construction sector. Okay, now, dearest participants, it's time. Without further ado, we move to the question and answer sessions. The organizer will send the link for your attendees. And then for this session, we will have approximately about 1 hour and 20 minutes for question and answers. And also for each keynote, hopefully you can give like take home message before we end this webinar. Please, to all of you who hasn't write down your question in chat, just do it. Just write it in the link that we send it. Mention your name and to which keynote you address your questions. Let's give a minute to check all the questions that coming up. For a quick reminders, right now we have around 400 participants online in Zoom and also YouTube. This webinar also runs on Instagram and Facebook of Fakultas Teknik Universitas Mulawarman. And let's widen our connections by connect to each others. So hopefully you don't mind to do like, subscribe our faculty channel, Fakultas Teknik of Mulawarman Universities. Now, if you have any question, please put that in the chat box. I will go to Sinse first. Prof. Hino. I understood Pak Fariza mentioned a question in the chat via Zoom, but hopefully if you don't mind, you explain it a bit so people in the YouTube channel also can get your explanation. The question is, first, by identifying soil condition parameter, can desaturation infer dequalification potential? Is there a potential for Is there a potential for such liquefaction in Saga land? And also following the questions, is soil gradation more decisive? That's the first questions. And the second question for you, Sensei, is there a quick way to get rid of the voids in the soil? And can we remove the moisturized in the in soil content by heating, just like what we do usually in the lab? That's addressing to Sensei. And then for Dr. Tri, Pak Tri, first question is about how we shall do it. I mean, one by one, or then I give you all the question and then we go through from one keynote to another. What do you think, Dr. Tri? Pak Tri, Silu?
I'm following you. Depend on
Oh,
I
you.
think
No
one to
problem.
one it will be more easier.
okay.
Yes, yes, I agree.
The difficult question is up to you. That's actually the difficult question if people asking you. Anyway, okay. Let's go to Professor Hino first. Sensei, the floor is yours.
Okay, but please give me with very simple English, please. Hello, hello.
Yes, yes, Sensei.
Mm. You give me question?
Oh, yes. There are
Okay.
three questions. I'm
Oh.
sorry. There are three questions. The first question is already mentioned in the chat of Zoom. But the first one is by identifying soil condition parameter, can this saturation infer the liquefaction potential? Is there a potential for such liquefaction in Saga land? And following that question is like, is soil gradation more decisive? I mean, just to give an idea for people who follow us in YouTube. The second question addressing to you is there a quick way to get rid of the voids in the soil? And the third, yes?
So first questions about the liquefaction, right?
Yes, yes, liquefaction.
So liquefaction, but the question is, Dr. Tori, please help me.
Is there, Sensei, is there any possibility of liquefaction in Saga lowland?
Okay, okay. No,
Okay.
actually, no, nothing. Because may I share the PowerPoint once again?
Okay, yes, please.
えーっと、
Thank you, Pak Tri.
そうね。
You're most welcome.
For me, the Dr. Tori's English is better. just a moment, please.
Yes, take your time.
The possibility of liquefaction in Saga lowland. So, for example, this is one of the example of our soil testing. So, please notice the left side of the information from this figure. So, from 0 meter by ground level, GL, so to 10 meter. So, we have a very thick soft clay deposit. So you actually sometimes we also find the sand layer in this soft clay layer, but fortunately in the case of Sagaloran, the covering of soft thick clay layer is very much. For example, more than 5 meters. So if any earthquake hits Sagaloran, so we cannot easily find the liquefaction problem. So actually, 4 years ago, we have a very experience to have a very big earthquake from Kumamoto. I think later on, all the participants can check the location of Kumamoto using Google Map. So 4 years ago, so the Kumamoto earthquake also hit Saga lowland. So that time the magnitude level is very high for Saga lowland. But fortunately, in Saga lowland, actually the shaking is very serious. But we could not find out any liquefaction problem in this lowland. So therefore, in the case of Saga lowland, we don't worry about the liquefaction effect too much. The answer is okay?
Yes, yes.
Oh,
Arigato.
okay.
And the second question, Sensei, is there a quick way to get rid of voids in the soil?
Sorry, Dr. Tori.
Is there a quick way? I
Oh.
mean, the effective way to get rid of the voids in the soil?
Sensei, can we measure the void ratio in the easy or quick way?
Sorry, sorry. High what?
Yes, measure the void ratio.
Void ratio?
Hi.
So no, you mean how we can measure the void ratio?
Yes, in the quick way. Hi.
Quick way?
It means very fast. Very fast.
Very fast what?
Yes. And the most efficient.
Sensei,
Yes.
when you measure water content, we need to
Okay.
put it in the oven for 24 hours, for example.
Okay.
So,
Oh.
is there any quick, is there any quick way to measure the void in the soil?
Quick way. So actually nothing. So
Yes.
at least we need one day. One day. For example, what I say. So from soil testing, in the case of soil particle density in Japan, using the symbol as rho. In SI unit, this is called gamma S, right? So for testing for soil particle density, actually we need 4 days, right? 4 days to obtain the results. Then the water content, in the case of water content, 2 days. So how we can quickly obtain the information of the void ratio. So at least we must measure the water content with it needs 2 days. Then on the other hand, in the case of this slide, we also show the total density or wet density or unit density of low T. So this one, we need only 10 minutes, right? So to obtain the void ratio information as quickly, at least we need 2 days.
Okay.
2 days, 2 days, 2 days. But in the case, sometimes we assume that actually the soil particle density's value is not drastically changed. So in the case of Japan, so sometimes we assume the soil particle density lowest as 2.65 averagely, right? So actually, we must measure the soil particle density. But firstly, we can assume that in the case of this soil, the soil particle density value is 2.65. But after that, we measure the total density and also water content. But unfortunately, in the case of water content, it needs 2 days to obtain the result. So after we obtain the water content, we can calculate the void ratio, as I already mentioned in my lecture. I believe it is a more fast way to obtain the information of void ratio from the soil. The answer is okay?
Okay. Arigato, Sensei.
Okay.
One more question.
One more.
Yes, it's about the removing the moisturizer contents.
Removing what?
Removing the moisturizer content. What do you call it? The level of water in the land. I hope I mentioned it right. In the lab, you remove the moisturizer content by heating. But in the real practice, can we do the same practice, or we can use another tools or methods? How about that, Sensei?
Oh, I'm sorry, but I cannot hear the sound well because my ears has a problem.
Oh,
Dr.
okay.
Tori, so Dr. Tori,
Yes.
please
Yes.
help.
I'm sorry, Sensei.
No, no,
But
no, no. It's okay.
yes.
Sorry also.
Yes. The question is about if you removing the moisturizer content from soil, if you use laboratory, you heating that soil. But in practice, can we use the same practice or that method to remove the moisturized content from the soil?
You mean how to heat the soil in the field?
Yes, more or less. I assume that the question, that's the aim of the question. I hope I understand it right.
Sorry,
So
sorry.
the question, Sensei, can we heat the soil in the field
Well,
to reduce the water content?
yes, because you usually, this participant asking, in the laboratory, you usually remove the moisturized content from soil by heating. But can we use the same method in practice? I mean, outside the laboratory, yes.
In the field, yeah.
Yep.
I'm sorry, but I can't understand, Dr. Tori, please help.
Yes.
Sensei, usually we measure the water content in the laboratory.
Okay.
Okay. Now the question is, can we measure the water content of the soil directly in the field?
Yeah. Actually, there is a technique. There is a technique. So one of the technique, several years ago, we employed one technique called, just a moment, so I will show it in chat, okay? It is called RI. The RI, so radioisotope penetration test. Radioisotope. So if we use the penetration of the cone with radioisotope, then so we can directly measure the water content from the field. So we don't need to bring back the soil to the laboratory. So if we apply, so do you know the one of the way that, so I mean the radioisotope cones like this, right? Penetrate to the foundation. So that time this penetration part also has a radioisotope. What I say, nuclear, Dr. Tori.
Sensei,
Nuclear. Yeah.
Sensei, can we heat the soil in the field directly to reduce the water content?
Can we what?
Can we heat atsui ne atsui? Can we heat the soil in the field? Can we heat to reduce the water content?
The technique also we have, but the cost is very expensive now. Yeah. That's why recently, instead of using heat, we apply the ground, the vacuum. So actually, so there are various ways to reduce the water content from the field. I think in today's Dr. Tori's presentation, so you introduced us about PBD, right? No.
No, another
PBD,
topic.
no. PBD
No.
is another topic. Yeah. But we can also apply the heat to the ground. But problem is that the cost is very expensive. So we don't usually apply the technique to improve the ground.
So may I add some information, because in this Monday we have also a lecturing from Professor Marolo from University of Manitoba, Canada. He said about heat transfer in the soil. It's a quite new technology for soil mechanics. So according to Professor Marolo, he mentioned about the heat transfer in the soil, like heat transfer in the soil. It's quite new technology also in soil. So I think in the future we can do it in this way. But now it's only the preliminary situation according to Professor Marolo.
But actually, I cannot agree the technique, So if we apply any heat to the ground, maybe the depletional environment drastically change. So, for example, in the case of Japan, right? So when we apply the heat technique to the ground, so after that, the arsenic concentration become very up. Oh, so that's why at least in Saga lowland, I never apply the heat technique
Okay.
because
Okay.
geo environment changing drastically.
Yeah.
Mm,
Yeah.
mm,
Arigato, Sensei.
okay.
For those who give the questions, you feel free to give feedback, comments, and I can ask again to Sensei whenever you don't get the point. The next one, I will save to Pak Tri. Pak Tri,
Yeah.
ada dua pertanyaan. Sorry, changing automatically. The first one, if there, I hope I catch the content of the question right, Pak Tri. But I will mention in Indonesian if in case I translate wrongly. If there is land subsidence, it's related to your presentations. There is like what a graphic, and then if there is land subsidence, can the construction that you offer can be used in this area? Because logically, it will make the rigid concrete above could be damaged.
Can you say in Indonesia?
Oh my goodness. Okay. Thank you. Well, apologize because my core expertise is really not.
Yes.
Jadi
I'm sorry.
berdasarkan grafik yang ditampilkan tadi, Bapak menjelaskan ada apakah terjadi penurunan berdasarkan grafik yang Bapak sampaikan tadi jika konstruksi tadi dipakai, karena kalau diaplikasikan akan membuat beton rigid di atasnya itu akan rusak.
Oh, okay. I can follow.
Okay.
Okay.
Sorry, Pak.
Okay. So very good question. Actually, I will try to explain as simple as it. Actually, this is very complicated explanation. It takes 1 semester to make you understand, but I want to make it very easy. Okay.
10 minutes.
So before you construct the rigid pavement on the top of the embankment, we need to firstly we need to construct this kind of constructions. Okay, so what I'm talking in my I talk in my presentation is before we construct the rigid pavement in the top of the embankment. Okay, this is the initial stage of the construction. So initially first, so when we face the soft ground, so the main problem is the settlement to the soft soil. So firstly, we have to manage the problem of the settlement, okay, by using this kind of timber, anything, PVD, like a person Hino mentioned before. After that, this reinforcement finish, and then we construct the rigid pavement at the top of the embankment. So we hope in the future there is no more settlement because already finished before we construct the rigid pavement. I hope this can answer the questions.
I do hope the participants hear that.
because if there is already rigid pavement in the soil, we cannot do anything in the below because we cannot destroy the rigid pavement because we need to put everything below the rigid pavement. So rigid pavement constructed after the reinforcement finish. So we hope there is no more settlement after construction finish. Okay.
Okay, that's very short and quick.
yeah, because it takes 1 semester for understanding this phenomenon.
Okay, or perhaps for those who raised the question, you can contact Patri further.
Yeah,
with
Most
explanation.
welcome. Please contact me.
Yes.
This is my
And
area, so I can explain everything.
thank you very much, Patri.
Okay.
And for your information, all the presentation will be uploaded in Fakultas Teknik website, so feel free to download and contact the keynotes. Okay, next question, Patri.
Okay.
I hope again translated it right. Understood.
Okay, you can go in first, in English first.
Okay. So considering the East area, East Kalimantan areas, when we talk about the mitigation and adaptations, what could we do? I mean, in terms of the condition of the soil for the contractions.
Oh yeah.
This time is
Before
flat,
you, yeah, I can understand. So before you do the construction in the like a Samarinda area, so you can see in my previous presentation. So Samarinda is covered by soft soil. Okay, so there is a problem when you do the construction. Like for example, if you build a high-rise building, so you need the more complicated foundation on the structure. So my suggestion is better you have like a database of the soil condition. I mean the beneath the surface, the soil's stratigraphy data. So it's the best way. And then after that you can make a mapping, and then you can arrange this area is quite high potential of damage, and then this low potential of damage, and etc. So my conclusion is your area is according to the map from ESD energy, what is in English, SDM, some energy ministry, something that distribution of soft soil in Indonesia, especially in East Kalimantan. So there is a potential of soft soil. So this soft soil is quite give problem when we construct the structure on the top of the soft soil. So we need a site investigation, more detailed site investigation, like that.
Okay, that's talking about the mitigation, but how about the adaptation? I mean, we talk about already there is a building constructions.
Yeah, that's a good idea. That is for our research topic also. So how to overcome the problem if the existing building. So many technology now, many technology we can use. For example, if to reduce the settlement, we can use a grouting to increase the density of the soft soil material. And then also we can the grouting, like inject some material to increase the density of the soil, for example. And then one is the most important in the Samarinda is actually is land subsidence.
Okay.
Land subsidence is different with settlement. Yeah,
Okay.
so that's why I am asking you the Indonesian translation, because if you use land subsidence and you mean it is settlement, is quite different.
Okay.
Land subsidence in the city is if you have a like water pumping in the water table, you have a water pumping, and then the land is going down. It's called the subsidence. But settlements without any load in the top of the soil, you just call it subsidence. But settlements only happen when you put the load in the top of the soil. So it is quite different.
Okay.
So yeah, the problem in Samarinda, I believe, is some of this land subsidence problem, because now also in Makassar we have a land subsidence, especially also in Jakarta. Jakarta maybe around like 30 centimeters per year or something, some area, but average 5 centimeters, the ground is going down like that. They call it land subsidence. So why the problem of land subsidence arise in our country, especially in our big city, because all the water subtracting from the water table. Okay, we suck. We suck the water from below the ground, so it creates land subsidence. So we need to be careful about the water pumping from the ground. So that is like a mitigation also. So the limit. I think in Japan they already prohibit using water pumping in the soil. Is that right, Hino Sensei?
Yeah, I think so. I agree.
Yeah.
But so if possible, the people should not groundwater pumping.
That's
if
right.
possible. If possible.
Yeah. But
Yeah.
the problem is in Indonesia, everybody use the water pumping.
Mm. So recently, in
Yeah.
the case of Saga Lowland, so as already you know that the land subsidence problem in Saga Lowland also was very serious, right?
Yeah.
But recently now, all the what I say, we drastically changed the water system. We stopped to depend on the groundwater pumping, especially for the rice, paddy field.
Yes. Yes. Yeah.
So if
Yeah.
possible, the groundwater pumping, so we should not do that.
That's right. That's right.
Mm,
So the main problem in the lowland city is
mm,
land subsidence. Yeah,
yeah.
because the level of the ground is tend to going down, and
Mm,
so we need to be careful about the land subsidence.
mm,
Actually, this is the good question, but accidentally that is not the meaning of land subsidence by the questioner.
mm.
Okay. Yes.
Okay.
That's also I learned new thing here, the difference between land
Yeah,
subsidence and also
and
settlement.
that's
Because
right.
Indonesian, if you just said generally, it's just like penurunan tanah.
Yeah, they're going to Google Map, Google Translate. So when you type penurunan tanah in the Google Translate, they show you land subsidence, but actually that is not.
Thank you for this information.
And also before I forgot, so I
Yes.
want to add some more information about liquefaction. Liquefaction only happen in the soil, granular soil. It means only in sand. So usually, like a Saga plain, and then I think in also in Indonesia. So our marine is like a marine clay. So the possibility of liquefaction is quite small. The liquefaction only happen to the sand, for example. Yeah. So if the soil is not sand, so the potential of liquefaction is quite low. There's
You
more
mean that's,
add more information about the
okay, thank you.
liquefaction.
That's you mean for Indonesian or for East Kalimantan?
I think Kalimantan is quite low possibility, maybe, but I don't know. I don't know the data. I don't know the data, but according to if you have a soft soil, so you are quite safe with the from from liquefaction. But in the area with the ground covered by the sand or granular material like a sand, so there's potential for liquefaction. So be careful with the reclamation. Reclamation sometimes use sand for the material. So this kind of material can create liquefaction during the earthquake. So I don't know about the detail Kalimantan soil profile, but be careful with the sand. If there is a sand, there is potential of liquefaction. But there are many things also involved. But be careful with the early warning. If you have a sand, be careful.
Yes,
Sand
that's
layer,
very
I mean.
yes, that's very insightful information. By the way, Pak Tri, just to think it lovely, I mean, compared to what Sensei mentioned before, that in Japan is rarely we find people doing water pumping, but here in Indonesia, it's like a common, it's like a
That's
daily
right.
life.
That's
Particularly
right.
if you live in the remote area, it's
That's
hard
right.
for you to get the water, a clean water system, and
Yeah.
people just do it water pumping. So can I say something like you need like shaping people behavior to implement this kind of technology to the society?
Who wanna ask for Hino or me?
No, I mean,
want to answer for Hino or me? Yeah,
I mean, we can
yeah.
make
So the
comparison
problem,
between
yeah, the
culture.
problem of land subsidence, my experience only in the city, because in city has a big burden, big load in the city. But if you use in the in the country area or rural area, there is no burden to the soil. Maybe it's not so damaging. But if you do the water pumping in the city, there's a big problem. Only in the city, I think, because if you do it in the in the rural area or in the countryside, maybe not so much different in terms of land subsidence. Yeah, in terms of land subsidence. But
But
water pumping, yeah, okay, please say.
no, no, Dr. Tori, but in the case of Saga lowland, so we have a
Right.
big farmland.
That's right.
Farmland.
That's
Yeah,
right.
yeah,
That's
yeah.
right. I mean,
That,
in Indonesia case,
yeah.
let's say.
Mm,
Indonesia case.
mm. So that's why now, so when we talk about the development of lowland, we should consider not only the ground or geotechnical engineering problem, but also water.
Yeah.
Water management, water quality, the viewpoint also. At the same time, it is very important viewpoint, I think. Hmm.
Okay, so you mean like just particular in the cities area, the people need to be aware with the land settlements, but not in the remote. Am I
Yeah,
right?
I think for to prevent the from land subsidence, okay,
Okay.
to prevent from land subsidence. But if you do it in the remote area, but the huge amount of water pumping also creates some problems. I mean, like an individual water pump in the remote area, maybe still not problem in terms of land subsidence problems. But if you do it in the huge amount of volume, I mean, the quantity of the water pumping equipment is very, I mean, is huge. So it's also some can create some problem. But in the city, I suggest please stop doing with the water pumping because it creates land subsidence.
Well, actually, that's free, Pak.
Yeah. Even in the houses, I have water pumping, but I only use it only for like critical situation. For example, there is no water from pump. Pump is a official water company in our country. But if there is no pump, so we use water pumping. But it's only for critical situation.
Okay.
So it's very common in Indonesia. Every house has a water pumping system.
Okay. Okay. Yes. So I can like make, well, for implement this technique, like or not, you need to connect to other fields.
Yeah.
People doesn't want to do the water pumping, but because of we don't have water, clean water system, people need to be aware and make like
That's
precaution for themselves.
That's right.
Okay.
That's
Thank
right.
you, Patri. Now we shift to Silu. Give me a second, Silu. I need to share something about the link of attendees. Just give me a second. One moment. Yeah, done. Okay. Silu, it's very nice experience, by the way, about the life cycle costing on the housing. I mean, to be frank, as far as I know, by heart, I don't know by heart, but as far as I know, I mean, we haven't done further research on calculate life cycle costing on housing. So I think most of the people attending this webinar is people from building and construction and civil engineers. So I hope they can give like, maybe I missed the result on that. But the question is, what is the basic thing if we would like to make like calculation for life cycle costing? I mean, as far as I understood from the explanations, you take an example of house. Yeah. So, and how we can apply this life cycle costing? What is the first thing we need to prepare, and how we do it from that step? Thank you.
Yeah. Thank you for the
Great.
question.
Yeah.
It's really interesting one. For the life cycle costing of the building, first you have to need a data. But first thing you have to know like in which life cycle stages you want to focus. It is always important to consider the whole life cycle from the construction till end of life is, so you will know the future cost as well, like and what is the cost in throughout the life of the building. So once you set your system boundary, you can then collect the data, like for example the cost of the material in that site, including the cost of labor and the transportation cost of the goods and the materials. So once you have all this cost, then you can calculate easily by applying the net present value cost. Um, with the net present value applying in different life cycle stages, you can easily calculate the life cycle cost of different life cycle stages.
Okay. And can we apply that to the bridge also? I mean, or any constructions?
Anything, like you can apply life cycle cost in any product or process, everything, like a phone, building, bridge, roads, laptop, everything.
Okay.
Because when we buy something, a car, or let's say, we just consider the investment cost, like the cost we are paying in the beginning, but we don't consider the cost in the future. So by doing the life cycle costing beforehand, before buying a car, let's say, then you'll have a clear view, like vision throughout the money you are spending throughout the lifespan of that car. This also helps in decision making, like if you are in dilemma to buy different brand of a car, then you can calculate the life cycle cost of these three or let's say different brand, and then you can easily choose which one is more cost effective in the long run.
Okay. Just to think it, I mean, just to think it lovely. If you talk about the bridge, taking as an sample
Yeah.
in the subsoil. So if we would like to find out and make calculation for this life cycle costing, perhaps you can give us like an example and which part that we can focus and then go to the rest for the process.
I mean, it also depends upon which component you want to focus. There is always a flexibility of choosing the component. Again, I said that it's always better to consider the whole bridge, like a beam and foundations, and also the bridge, and what kind of material is used on the different component of the bridges. You have to know, and also the quantity of the material needed in different component of the bridges. So if you know all these things, then it will be very easy to calculate the life cycle cost.
Okay, that sounds easy. That sounds.
But it is indeed very data intensive.
May I give a question?
Oh,
Yes,
okay,
please.
Patri, please. No, I'm sorry. Wait for a second, Patri. I don't mean like saying that's easy. I mean, we said it's simple, but actually in practice, it's really, really difficult. I know it.
Yeah, it's really data intensive, so it's very time consuming. You need to collect a lot of data. It's
I
not
know.
only about the quantity of the material used in different component, but also you have to know the source of the material where you are buying. So that you can also calculate the distance from that source to the construction site. So you also need the transportation distance cost, the labor cost, the driver who is driving and that car from the source to the construction site, and the production cost, everything you have to consider.
Wow. Yes, Patri, please.
Okay, thank you. Thank you very much. Dr. Silu? May I
Yes,
call you
please.
Dr. Silu? Okay,
You
nice to
can.
meet you.
Same here.
So, Dr. Silu, as I mentioned in my presentation, in doing soil reinforcement, we use a timber pile, okay?
Yeah.
So the problem is, can you give some comment about the life cycle of this by using this timber? Actually, this timber came from forest,
Yeah.
for example. So how we make sure the availability of the timber, this timber is we can, for example, we can use anytime. So depend on the availability from the forest. So
Yeah.
can you make some calculation that is a cycle of this timber? Yeah, this timber plant or something.
Yeah,
Timber
yeah,
tree
definitely.
or tree.
You mean the, sorry to interrupt.
Yeah. Okay. I think you got my point.
Yes, you mean the life cycle cost or life cycle
Yeah.
assessment? These are two things
Cost, maybe
again.
firstly cost.
Cost.
Yes.
If you want to calculate the cost of the timber that you're using there, first you have to know what is the lifespan of that timber using in the settlement. Can you give me the answer of that first? What will be the tentative? Like, you don't need to give an exact time
Yeah.
lifespan of the timber over there.
Yeah. Usually in civil engineering construction, we need the availability of the material as soon as possible. For example, like a 2 or 3 months, something. But we don't know how fast the tree will grow. So
Yeah, also it depends upon the type of the timber.
yeah.
The availability is also depends upon the type of timber, and also the machine that is used to cut those tree, and also transporting that timber
Yeah.
from forest to the site. And also you need
Yeah.
to make it yeah, you have to frame it according to the need you want. So you have to calculate all these costs. So that will be the cost only for the construction. But if you want to consider the future cost, like the use cost and maintenance cost, and also the end of life cost, like what after, like after the end of the service life, what you'll do with those timber. So you also need some cost to dispose or incinerate. Yeah, I don't know. It depends upon the place again. So if you know all these costs, then you can calculate the life cycle cost of using the timber easily. Yeah. But if you want to do that, yeah, let's collaborate and do it together.
Sure, of course, because okay,
Another
because
opportunity to make
yeah,
collaboration, Patrick.
Yes.
that's right. I agree. So let's have a collaboration in the future. What
Yeah,
do you think,
definitely.
Hino Sensei?
Well, indeed, the life cycle costing is very daunting, in my opinion, and challenging, of course, in terms of data, particularly here in Indonesia. I mean, it's not easily you collect the data because you
Yeah.
mentioned before the raw material we need to have, like the database. Maybe is there any like software, perhaps that you can like recommend for like the beginner to learn about the LCC and LCA?
Yeah, we're using Gabi and Sima Pro for calculating life cycle assessment and also for life cycle costing. But for the life cycle costing, it differ in different reasons because the labor cost is totally different than in Indonesia and Netherlands. And the material cost will be different. So it's always better to collect the primary data for life cycle costing. But for the life cycle assessment, we have like an average, like Invent database that we can use easily. That's kind of like average data from Europe or from Asia, US. So it's not like exact data or the exact result we'll get, but we'll get the tentative results from using that database. But however, using a primary data is always the accurate one, especially for life cycle costing.
Yes, yes. Um, so I still waiting for another question for you, Silu, but I can't find it in the link. So I will come back to you once I send another question to Sensei.
Okay.
Tri, perhaps I need your help in this area, Pak Tri.
Okay.
It's
Okay.
very well.
So maybe you can in Indonesia maybe, so I can easily
yes,
pick the right English.
okay,
Because in civil engineering terms sometimes quite different with the ordinary English.
I know. Yes, my
Yeah.
background is industrial engineering and then sustainable.
That's right.
management,
That's
so
right.
it's
That's
quite
right.
far from my
So
expertise.
if you go to Google Translate, when you type tanah, so they will show you land, but actually that is not land; it's a soil.
Yes.
So better in Indonesia. Sometimes
Thank you very
quite
much
confusing.
for
Yeah.
this informative feedback. By the way, in Indonesia, pancang-pancang di bawah timbunan, maybe is hariake, pancang-pancang bawah timbunan. I don't know what do you call it? Definitive term in civil engineer, but
Yeah.
the question is how to what is it called? How to develop pancang-pancang di bawah timbunan.
Okay.
I hope you catch it right. At least you know what I mean.
Okay. Hino Sensei, the question is using a pile beneath the embankment for Ariake, for soil in Ariake. The use of piles. The use of piles.
Under the embankment?
Yeah, under embankment in Ariake soil or something.
Under the embankment, we don't use pile.
What kind of structure you use?
Usually in the case of Saga Lowland, we are making the highway. So in the case of the construction, we use deep mixing method. Deep mixing method, but I don't know everybody can understand the method or not.
Yeah.
Perhaps you can give us like a brief explanation, Sensei.
Deep
about the
mixing.
method. Yes.
Deep mixing method. So
yes.
deep mixing method. Just a moment.
Yes.
During that, I can explain you in Indonesia, Sensei. Please find that information.
Yeah. Just a moment, please. Just a moment,
Yeah.
please. I should prepare it. I have a good.
Jadi Ibu Juli.
Yes.
Ini mungkin yang bertanya mungkin nonton ya.
Yes.
Jadi mereka tidak pakai tiang pancang, ya. Tetapi mereka ganti dengan yang mereka sebut dengan deep mixing method. Metode mencampur dalam, pokoknya memang saya juga tidak tahu bahasa Indonesianya itu. Jadi saya cuma sebut deep mixing method juga. Yeah, okay, I really.
So may I? So what is this? What this? So please give me 3 minutes, right?
Okay.
Oh. Deep mixing method is like this one, right?
Yeah.
Oh, okay.
This. So what a deep mixing method. So we in this method we use cement or lime, sometimes lime but cement slurry. So because this machine has what I say, this one, the wing at the edge. Then so when the wing penetrates to the ground, so at the same time the cement slurry also go. Now the wing is rotating, the excavating, and also sending the cement slurry into the ground. Then please continue. Then finally, we make this kind of soil cement column under the embankment. So please continue. So this is deep mixing method. So now, so this is Saga lowland and the road called RHC coastal road. So in the case of Saga lowland, we usually apply the deep mix method under the embankment to countermeasure the soft ground. Is this okay?
Sensei,
Hi,
yeah.
hi.
Do you have any experience by using pile in
Pile.
Saga?
So in the case of Saga, of course, under the building,
Yeah,
so we install the pile. Pile.
but for the road or pile, okay.
Yeah, yeah,
You
yeah.
mean bore pile or driven pile?
Uh, driven pile. Another is what?
Bore pile.
That one.
Bore pile.
Yeah, yeah, ball
Yeah.
pile.
Okay, okay.
So driven in the rural
It's good.
area, okay, but in the
Yeah,
city,
that's right.
yeah, so we cannot
Hmm.
apply it. Yeah.
Yeah.
Mm.
Ibu Yuli gimana? Bisa mau?
I'm sure people who give this question are listening to us, Pak. So I'm just waiting for the feedback and any comments or any other further question if just he or she doesn't understood the explanations. I will continue for the next questions, Pak Tri.
Yeah.
Well, actually, it's about the policy thing. I mean, I mean, I mean, we talk much about the technique, the methods, and you can say we know how to do it, but sometimes the technique, the method could not be implemented because of many variables, many factors. So in this case, suppose taking for examples, maybe the airport, new airports, where there is the condition of the soil like soft soils. I mean, just think it's practically how we can make it like win-win solution in this case. We know the technique, but there are some variable around there that force us can't do this correctly. So in your experience so far, because you mentioned you've been to Merauke before, so you must facing this kind of problem. And I'm just curious how in Japan facing the same problem. Maybe Sensei can edit the answer. Please, Patri.
Yeah, yeah. I don't have any answer in political overview or policy overview because it's not my expertise. So if you have a problem, so I think generally speaking, geotechnical engineers is created to solve the problem, I think. So our field is created to solve the problem because that is due to the lack of knowledge about the soil. Some people construct the structure is in inappropriate way due to the lack of knowledge about the soil. So us is a geotechnical engineers is there to solve the problem. That is my question.
Oh yes. So I think it's also open an opportunity to make collaboration with other
That's
fields.
right. That's
Yes.
right.
Well,
That's right.
well, a lot of opportunity. I mean,
Yeah, yeah.
that's
Samarinda
what
is
we're
lowland.
today.
Samarinda is lowland. Makassar is lowland. Saga is lowland. So we are interconnected each other, I think. What do you think, Sensei? So we need to expand the lowland community because
Yeah.
the lowland community creates so many problems.
Yeah.
especially in the soil. So many
Yeah.
problems in the lowland city.
Yeah. So I strongly believe the lowland is a very important viewpoint for us.
Because usually the city built in the lowland area and
Yeah.
near the sea, near the beach.
Yeah.
Most of the city built near the beach, so
Mm.
near the shore,
Mm.
in the shoreline. So the
Mm.
shorelines create so many
Mm.
problems in terms of soil condition.
Mm. Yeah, I think so. I really agree with you.
So
Mm.
maybe in the future we can make some collaboration
Yes,
about the
yes.
lowland.
Mm.
Yeah.
Of course.
Yes, just to make a highlight with the doctor, try to connect with Dr. Silu presentation that she mentioned about LCC, opportunity to take further research and future research, how to combine LCC and also how the technique, material using, how to, what do you call it, tackle the challenge on the lowland, soft soil or lowland part. I'm not sure about this, but at least you know what I mean. And the second one, maybe try to make a broader, how to implement the collaborating with colleagues, friends from policy making. I think this is also one of the challenging for Indonesian, particularly.
Yeah. Nowadays there is no restriction between subjects. For example, I'm geotechnical and Dr. C in the recent days, so there is no boundary between knowledge. So you can imagine, like 5 years ago, when I start to do some research about using bacteria. So everybody just shocked, huh? What do you want to do with bacteria? But now I have two PhD students already graduated with this kind of subjects. So this subject is quite closely related with the chemical industrial, but the implementation in the civil engineering. So now there is no boundary about the knowledge. So we can collaborate with any field in the world.
Well, thank you. I saw Hasanuddin's prize hand. I'm not sure about that, but let me check in the chat. Okay, let's see. Let's just wait for the question coming up. I will go to Silu. Yes. Come back, referring to your presentation before about the circular materials. Perhaps you can give us like an example based on your research on Himalayan, that taking into account the circular material that that has proven to be more efficient in the long term rather than what you call common material that we are using now.
Yeah, thank you for the question.
Yeah, I'm just thinking locally, maybe we have like similar situation because we are from like growing countries.
Yes, it is always recommend to have a material nearby. Yeah, if you can find the material, like for example, concrete or cement or steel nearby the construction site, it's always recommended that, because that always reduces the transportation cost. And for the circularity, it is it's better to go with a biomaterial, for example, like a timber or bamboo, which is biodegradable in one sense, so that you don't have to take in account to how to dispose them. Either you can burn it and use as a inercy, or you can just dump it and then it can become fertilizer. And the other aspect is if you are applying some circularity principle in the building sector, then it's always better to design a building in a way that it can be dismantled easily. For example, if you have to like replace the insulation in the wall, then you don't have to break down all the wall. If you design in a dismantle way, then you can just easily dismantle the wall and take out the insulation and replace them with another insulation, because insulation has a lower lifespan. So yeah, it depends upon the location of the material, the biodegradable material use, and design with the disassembly. So these three things are very important in the circularity in the construction sector.
That's very, very interesting, by the way. I mean, need like further experience both to identify what is the most effective and efficient in a way.
Yeah, and also I heard in Indonesia, you have a lot of fly ash from the coal company.
Layer?
So maybe
Sorry?
you can
Layer?
fly ash.
Oh, fly ash. Yes, fly ash.
Yeah. So you can reuse that fly ash as a cementitious product and build a bridge or roads. Because recently we're also doing some research on rice husks. I'm from Nepal, so we do have a lot of rice and a lot of rice husk. So we are doing a research on using a cementitious product from the rice husk as, which actually has a higher cementitious value than the cement that we found in the shop.
Yes, in one way.
Yeah, so you can also, like what I'm saying is, you can also reuse those material that are abundantly available in your region.
I believe many civil engineers also quite done some research using the fly ash in the construction and building. I don't know by heart. I'm just guessing. Just considering fly ash, most of people are considering here as like hazardous material. But in a way, try in small scale already implement for like a pilot project for pavement, and also from I don't know what in English, bataku, Pak Tri.
Bricks.
Oh yes, thank you, bricks. Thank you very much, Pak Tri.
Yeah, a couple of years ago, I have undergraduate students doing research about the soil stabilization by using fly ash, and then what is it from rice field or something? They reutilize that waste material as a soil stabilization. So it's a good idea also.
Yes. Yes. I don't see any other question arise. There is someone mentioned. There is a question, but I can't find it in chat. So I think I can give to Sensei to give like a final remark or so. Sensei, please, would you mind give us like a final remarks or concluding what we discussed today? Like take home message for all of us.
Final remark.
Take home message.
Please come to Japan.
Yeah. So please come to Saga Lowland.
Yeah.
So, because unfortunately now we are under the very serious impact of COVID-19. So, especially this year, I cannot visit Indonesia. But of course, in the near future, we strongly believe that the impact of COVID-19 will stop, finish. Then after that, so we can collaborate, research more and more. So today, what I want to say in my lecture, so, so every researcher or every engineer think that, of course, my knowledge is good. But the most important thing, especially in geotechnical engineering, the sense also very important. So especially for young participants, if you are here, so if you have a chance to visit any field, especially the construction field or problematic field. So if you can visit there many times, so please visit, always visit to the field. Then observe the real situation. Thereafter bring back the memory to your laboratory. Then so please study more. So it is my final concluding remark today. Thank you very much.
Arigato, Sensei. Please, I'm shifting to Pak Tri. Please, Pak Tri. Oleh-oleh buat
Okay.
kami semua.
In English or in Indonesia?
Please, whatever you convenient, Pak Tri.
Okay. So to everybody who has time for watching this lecture, so thank you very much. So I'm great. I have a great honor to invited by Universitas Mulawarman. Thank you very much for Pak Tamrin, Bu Juli. Even we just met and then we already like know each other for a long time. Okay. So thank you very much everything. But my closing remarks is I want to quote some words when I was doing my PhD. My professor told me that think globally, but act locally and personally. That is the yeah. We can think bigger idea, but there is no meaning if only idea. But we have to realize it like act in the personally in your area, in the small area like that. So make your dreams become true.
Oh.
Okay, that is my close remarks. Thank you very much, everybody, for this wonderful opportunity. Thank you very much. Assalamualaikum.
Waalaikumsalam. Well, it's really interesting because last Monday, Dr. Laura Mora Franke also, I mean, the take-home message for the discussion is think locally, think
globally,
act locally. So it's very.
And I added with personally.
Oh, completely agree. Okay, I'm a supporter. Well, also, I think in one of a curriculum vitae of Sensei Hino is very interesting, contributing to the community and society through research and technology that is world class. It's very inspiring and motivation. Okay, please, Silu, give us something.
Firstly, I would like to thank Juli for inviting me, and also thank you for all the audience for your time. So take home message would be like stay sustainable and circular by acting like thinking globally and acting locally. And during this COVID situation, yeah, please stay safe and healthy.
Yes,
Thank you.
Thank you all.
Thank you.
Stay safe, everybody. Stay safe.
Yes. Well, we are still here. Okay. Thank you very much. Arigato, Sensei. Please mind my if there is some mistakes, the Japanese word that I said it wrongly. And also thank you very much for Pak Tri, for your help or for your support for this webinar. And also thank you very much, Dr. Silu. All of you already addressing us interesting topic, give us a very, very deep and insightful knowledge. So on behalf of Faculty of Engineering, we would like to thank you for joining us today. If there are questions that we haven't answered in time, we will open for any further communications.
Okay, sure. You're most welcome.
Dearest participants, colleagues and friends, and also ladies and gentlemen, finally we came to the end of the presentations. We would like to say thank you again for all the keynote speakers, for their time, their informative and interesting talk. Also, to our dear participants, may I thank you very much for your active participation in these sessions. Hope this talk bring benefits, not just for leverage our knowledge as individual, but also for our society. Just what I said before and what the keynote agreed before, think globally, act locally, and from individual. Start small, think big, but start small from yourself. So please, well, I call it like a small message. Don't forget to subscribe our channel, Fakultas Teknik Universitas Mulawarman, And this webinar will run till the end of this month, September. For more information, you can just Googling and visit our website, Fakultas Teknik. You can also register for the next webinars. Tomorrow we will have the webinar in the morning, starting from 9. We have like keynote from Thailand and from University of Andalas, Medan. So I hope you enjoy it all. Please apologize for any inconvenience during the sessions. Me as moderator saying Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Arigato sensei.
Thank you very much.
Thank you
Arigato.
very much. Pak Tri, terima kasih.
Thank you, Sensei, Dr. Silo.
Thank you.
See you again.
Thank you,
See you again
everyone.
in
Nice to meet
Netherlands.